I would like to look at a couple of facts when it comes to multiplying and dividing real numbers. So first we'll start with multiplication, and here I have 5 times 3, which I know the answer is 15. But what happens when you start introducing some negative numbers, like negative 5 times 3? So let's look up here first at this 5 times 3. Now I know the answer is 15, but the reason for this is it is repeated addition. You could think of this as we're adding 5 to itself 3 times. And well, 5 plus 5 plus 5 is our answer of 15. No surprise there. If I use the same idea on negative 5 times 3, this means we take negative 5 and we add it to itself a total of 3 times. Because each of those numbers is negative, when we add them together, the answer must be negative 2, in fact, negative 15. So this is a justification as to why a negative times a positive is a negative, and that's what's listed here in Rule 1. When we encounter this situation, the answer has to be negative. So one other thing to point out is that since multiplication is commutative, it should be that 3 times negative 5 is equal to negative 5 times 3, which is, here we have negative 15. So it doesn't matter if the negative appears first or second. In either case, the result will be a negative number. So next to my rule, I'll write this as if we have a negative multiplied to a positive, the answer is negative. And if you have a positive multiplied to a negative number, that is also negative. So that's what this rule is trying to tell us here. In example 1, let's just simply apply this rule. So I'll start over here and look at negative 8.1 times 12. I would actually start this problem by trying to just get rid of this negative so I don't have to worry about it. Since it's a negative number times a positive number, I know the entire answer must be negative. So now that I've decided this, all I have to worry about is multiplying 8.1 by 12. So you could use a calculator for that, but I'm going to do this one by hand. To multiply 8.1 and 12, I'll remove the decimal from 8.1 and just think of it as 81, and then when I get to my answer, I'll put that 1 decimal point back. So I'll multiply the 2, and I get 2 times 1 is 2, 2 times 8 is 16. I'll then move over to the 1. 1 times 1 is 1, and 1 times 8 is 8. I shifted over one place because we're in the tenths. I add these two together. We get 2, 7, and 9, and I simply just put the decimal point back that I removed. So here the answer is 97.2, but of course there's a negative in front of it. All right, let's look at this one here where it's just a couple, well, it's a fraction times just an integer. So again, here I have a negative, it's on the second number, but that does not matter. The entire answer itself is going to be negative. So now all I have to worry about is just dealing with, well, how do you multiply 12 sevenths and 49? All right, 49 is 49 over 1, so I'm comparing two fractions when I'm multiplying them together. And you could just multiply directly across, but I see that 7 goes into itself once and it goes into 49 7 times. And because of this, this problem is really 12 over 1 times 7 over 1. And since the denominators are all 1, this is really just 12 times 7. So if we multiply 12 and 7, you get 14, 84 is the answer. So the answer to this question is actually negative 84. So this is what it looks like to apply Rule 1. A positive times a negative is negative. So the second rule is, well, what happens if you encounter two negative numbers being multiplied together? So the answer is that it results in a positive value. And I'd like to just quickly maybe justify why this is true. And I'll go back to my negative 5 times 3. And we already decided that, okay, this is going to be equal to negative 15. What I'm going to do is look for a pattern. I'm going to decrease this 3 until I encounter a negative number and see if a pattern emerges. Here's what I mean. I'll leave the negative 5 alone, but I'm going to change that 3 to a 2. And obviously, no surprise, we get negative 10. Thing to point out is, when I decrease this by 1, this actually goes up by 5. No real surprise there. But I'm going to keep decreasing this value until I encounter a negative number. So I have negative 5 times 1, which gives me negative 5. And again, my answer goes up by 5. I then have negative 5 times 0, which is 0. Again, I'm increasing by 5. But what about negative 5 times negative 1? For this pattern to hold, we've increased by 5 every single time. So I added 5, I added 5, I added 5. For this to hold true again, I would add 5 to 0, making the answer positive 5. So a negative times a negative in this case made sense to result in a positive answer if we'd like this pattern to hold true. So this is not a proof of this rule. It is simply just looking for a pattern to hold with a previous rule. I'll write this as a negative times a negative is a positive. So now that we have at least justification for this rule, let's apply an example 2. I'll first point out that both Rule 1 and Rule 2 hold for division as well as multiplication. Let's look at this example first, where we're multiplying two fractions together. Since it is a negative times a negative, you can write this as a note. It's not necessary, but I know the answer is going to be a positive value. And again, all I'm doing then is ignoring the negatives at this point. And I'm just taking 8/5 and multiplying it to 20/24. So to simplify this, 8 goes into itself once and into 24 3 times. And likewise, 5 goes into itself once and it goes into 20 a total of 4 times, giving me an answer of 1 times 4 is 4, 1 times 3 is 3, an answer of 4/3. So you could write positive 4/3 or simply 4/3, those are the same thing. And you could write this as a mixed number if you'd like to. It'd be okay to write 1 and 1/3. So both of those are acceptable answers. Okay, now let's look at this division problem. So I'm claiming that rule 1 and 2 hold for division. So here I have a positive 1/2 divided by a negative 5/2. This means that my answer is going to be negative. One of them is positive, one of them is negative. The result is a negative answer. So to solve this, I want to know what is 1/2 divided by 5/2. And whatever I get, I'll place it here. Okay, let's see. To divide two fractions, we'll leave the first fraction alone and take the reciprocal of the second fraction. And once we do that, this simplifies very easily, where 2, both those 2's cancel to a 1, and we're left with an answer of 1/5. So the answer to this problem is a negative 1/5. And these are all the rules that we need for multiplying and even dividing real numbers.